Hi, I'm Joe James, and this is a continuation of my series on trigonometry, or how to solve triangles. In this video, we're going to learn how to use the sine function and its inverse function, arc-sine, to find unknown sides and angles in right triangles. So don't be put off by those names. They're big words, but actually not that complicated. You're going to see how simple they are as we walk through this video. But first, we're going to learn a couple of terms. So we should already know what a hypotenuse is. That's the longest side, or the side opposite the right angle. Let's take a look at this triangle here. Which side is the hypotenuse? Well, here is the right angle. Here it's obvious that y is the longest side. Between x, y, and z, y is the longest of those three. In case it's not obvious or it's hard to tell, look, y is also opposite the right angle. This is the right angle, and side y is opposite that. So here the hypotenuse is side y. Adjacent means next to or adjoining. Now, next to angle A, there's actually two sides. Side y, but we've already labeled that as the hypotenuse, right? So side y and side x. Since side y is the hypotenuse, what side is adjacent to angle A that's not the hypotenuse? Side x. So here, if we're referencing angle A, x is adjacent to it. And which side is opposite? That means the side that does not touch the angle. So which side is opposite angle A? On the far opposite side of the triangle is side Z. So in this example, in relation to angle A, side Z is opposite, side X is adjacent, and side Y is our hypotenuse. Now, if we were talking about this angle up here, it would be a different story, right? The hypotenuse would remain the same, but what is opposite this angle up here would be side X. And what is adjacent to this angle up here would be, well, side Z, right? So adjacent and opposite are relative to the angle that you're talking about. Whereas hypotenuse is an absolute because it's the longest side in the triangle all the time. You may be bored with this, but we're going to do one more exercise on adjacent and opposite because it's critically important to understand these before we move on to the trig functions. So again, the hypotenuse in this triangle, this triangle is oriented differently. So don't be thrown by that. Here's the right angle, right? Which side is opposite the right angle? X. So here x is our hypotenuse. Then we're going to find out for angle L, which side is adjacent? Which side is adjacent to angle L? We already said that x is the hypotenuse. Which other side is adjacent to angle L? Well, that's y, isn't it? It joins or touches angle L. So here, side y is adjacent to angle L. And which side is opposite to angle L? That means on the far opposite side, that would be Z. So side Z is opposite angle L. And then let's look at angle M. Angle M is over here. So the hypotenuse is going to stay the same no matter what, right? The hypotenuse, the longest side, is always the longest side. But the adjacent side depends on which angle you're referencing. In relation to angle M, Z is the adjacent side. Z is the side that touches angle M. So we're going to say the adjacent side to angle M is Z. And what side is opposite angle M? Well, that's across from angle M, and that is Y. So look, depending on which angle you're referencing, the hypotenuse stays the same because that's an absolute. It's the longest side in a triangle, and it's always opposite the 90-degree angle. But which side is considered adjacent and which side is considered opposite is dependent upon the angle you're talking about. So let's keep that in mind as we look at the sine function. So what is sine, cosine, and tangent? These are trig functions. What do they really mean? Well, they're nothing more than ratios of side lengths. That's all. That's all. It's not overly complicated. It's just the ratio of two side lengths in a triangle. So we're going to calculate sine, cosine, and tangent in the next 3 videos. We're going to see how these are easily used to solve for angles or sides of a triangle just by using the ratios of sides. You'll see how easy this is. So sine of n is equal to opposite over hypotenuse. Sine of any angle is equal to the opposite side over the hypotenuse. This is angle n. Which side is the hypotenuse? Well, the hypotenuse is opposite to the right angle, and it's also the longest side. So G is the hypotenuse. This is G. And which side is the opposite side? Well, opposite what? Opposite n. So which side is opposite n? That's F. So if we wanted to find the sine of angle n is an angle. If we wanted to find the sine of angle n, we could divide F by G. The length of side F divided by the length of side G will give us sine n. Again, that's just a ratio of these two side lengths. That's all sine n is. We're going to see how we can use that to solve problems. So in problem number 1 here, in the right triangle given, use the sine function to find the length of side A. First, which one is the hypotenuse? Well, that's opposite the right triangle. So the hypotenuse is 12, isn't it? Let's figure this out. H equals 12. Angle K we know because it's 40 degrees. K equals 40. And which side is opposite to angle K? Opposite to angle K is A. A equals the opposite. So those are the three things we need to know, isn't it? Let's see, now we're going to say sine K equals opposite over hypotenuse, and that's equal to A over 12, because we're just substituting in, we know the hypotenuse. So in other words, sine 40, because K is 40, equals A over 12. All we need to do to solve for A here is multiply both sides of our equation by 12. And if we rewrite that equation, we get A equals 12 times sine 40. All we did is multiply both sides of the equation by 12. And on this side, that canceled out the 12s. So we just got A. And on this side, we got 12 sine 40. So A is equal to 12 sine 40, and that is equal to 8.9. So that's the length of side A. We have to use a calculator to calculate sine 40. Putting that into a calculator gives us an answer really quick and easy. So on the iPhone calculator, you have to rotate your phone into the horizontal mode or landscape mode to get all these additional functions. If you're in the vertical mode, your calculator is not going to show you all these additional functions. So you need to rotate your phone first. And then you'll see the sine, cosine, and tangent functions down here in this red square, which is my red square. That's not going to show up on your phone. And one thing to be aware of, you'll see when you're in degree mode, you do not see anything right here. When you're in radian mode, this little rad will show up here inside this where I showed you this red box. And you'll want to click into degree mode by clicking this degree button down here to change yourself back into degree mode. If you're in radian mode, you're going to get a wrong answer. And another important note is with the iPhone, you put in the degrees. Let's say you're looking for sine 30, you would put in 30 and then the sine key. With the Android or Google calculator, you put in the sine button and then 30 and then equals. So the order of keys is reverse, whether you're using the iPhone or the Google calculator. On the Google calculator, you'll want to make sure that you're in degree mode. When you're in degree mode, you'll know because this degree button will be dark and the rad key will be grayed out. You click the sine, cosine, or tangent key and then the number keys. So if you're looking for sine 30, you would click sine 30 equals. So the order of key entry is reversed from the iPhone. It's not the same. Let's try a couple more problems using sine. In the given right triangle, find all the unknown sides and angles. Well, let's see, we know one angle. Let's see, this angle doesn't say, but it's 90 degrees. We know that because this little square thing here. So this angle is 90 degrees. Well, angle G, this is easy because we can use sum of angles for that. That's always a good place to start. So G is equal to 180 minus 90 minus 56, which is 33 degrees. So angle G we have already, that's 33. Now we still have to find sides A and C. Okay, we can use the sine function to find out what C is, can't we? Sine is, there will only be one unknown, right? We know what angle G is. So sine of G, let's write that out here. Sine of G, what is G? 33. Sine of 33 equals opposite over hypotenuse. Which side is the hypotenuse? Hypotenuse is C, which is opposite the 90-degree angle. So let's see. C is going to go on the bottom here, right? That's the hypotenuse. Opposite over hypotenuse. What's opposite angle G? 7. So opposite, which is 7, over hypotenuse, which is C. We don't know C. So now we've written out an equation for the sine of angle G. Sine 33 equals opposite over hypotenuse. Now we can multiply both sides by C. Let's see. C times sine 33 equals 7. And then we can divide both sides by sine 33, and we're going to get C equals 7 over sine 33. And when we calculate this on a calculator, we get the length of side C, which is 13.23. So here's our side C. We're done with that. 13.2, we'll call it. Now we can find side A. We could also use the sine of this angle, couldn't we? Or we could simply use the Pythagorean theorem. We know two sides of a right triangle. We can just use Pythagorean theorem to get A. What is A equal to? Let's see, it's the square root of the hypotenuse squared, 13.2 squared, minus the other side squared, 7 squared. And when we multiply that out, what we get for side A is 11.2. So now we have a side A of 11.2. So we've solved this entire triangle. We started out with the sum of angles. We applied the sine function to figure out what the hypotenuse is. And then we used the Pythagorean theorem to figure out what side A is. Let's take a look at one more practice problem using the sine function. Given the triangle above, find the missing sides and angles. Well, let's see. What do we have here? Uh-oh. We don't have either angle P or angle Q. We only have one angle, and that's this one, which we know is 90 degrees. So we know it's a 90-degree angle. Well, let's see. We know what the opposite of angle P is, and we know what the hypotenuse is, so we can use those to find angle P using the sine function. So we'll write sine P equals opposite over hypotenuse. Opposite of P is 7, right? Over, what's the hypotenuse? 12. So sine P equals 7 over 12. Now we need to use the arc-sine or inverse sine function to figure out what P is. In other words, we have the opposite in the hypotenuse. We need to figure out what the angle is. And we can use the inverse sine function to figure out what the angle is if we know the sine. So there are three terms for the same thing: arc-sine, inverse sine, or in a lot of calculators sometimes it's written as sine to the minus 1 power, although it's not really an exponent. It's a little deceiving. But you'll see it written shorthand this way, sine minus 1, because it fits on a calculator button. So these are all inverse sine. In other words, I know what the value of sine is. I want to find out what angle has that value for sine, which is exactly what we need here. So we're going to punch into a calculator 7/12, and we're going to take the inverse sine minus 1 of that, to get the angle. and that is 35.7. So angle P is 35.7. Using the inverse sine function, we got that. Now to access the arc-sine or inverse sine, cosine, and tangent functions, you'll click this second function key here, and then these keys will change from sine into sine minus 1 and cosine minus 1 and tan minus 1. So these are inverse or arc-sine, arc-cosine, and arc-tangent. So let's see, if this is 35.7, we can use the sum of angles to get angle Q, can't we? Q is equal to 180 minus 90 minus 35.7, and that gives us 54.3. So this is 54.3 degrees. Now we just have one side remaining, that's side A. We can use the Pythagorean theorem to get side A. So 12 squared minus 7 squared would give us A. So let's see, A is equal to square root of 12 squared minus 7 squared. And that's 144 minus 49. That's 9.75. So A is equal to 9.75. That's side A. Now we're done solving this triangle. We use the inverse sine function to find angle P, and then we used the sum of angles to get angle Q. And lastly, we used the Pythagorean theorem, since we already knew two sides, to get side A. I hope this video was helpful for you. If so, please click the like button and subscribe to my channel. I'm Joe James. Thanks for watching.